I'm known as GD2K online for reasons that aren't as amusing as you might imagine. I live in Scotland, where I run the Edinburgh Python user group. I'm an organizer of PyCon UK. I was a co-chair of DjangoCon Europe last year, so I keep busy. When I'm not doing that stuff, I'm a senior developer advocate at MongoDB. I've been there for nearly 5 years now, which is a surprise to everyone. I've got some notes for myself, which I'm not going to read out to you because they're not for you. So today I'm going to be talking about building a powerful autonomous assistant with AI. You can be the judge of whether it's powerful by the time we get to the end of this talk. I'm going to be talking about what an agent is. There's a lot of people talking about it in the AI space these days. I'm not an expert, but I got excited by the idea and I kind of wanted to build something around it. I'm going to be talking about the tools that I'm using to build this autonomous agent, and then I'm going to spend most of my time in a Jupyter notebook kind of running through the actual code for building this thing, and then we'll have some kind of thoughts and some sort of extra homework if people want to take some of the ideas and work with them. So what made me want to build an autonomous assistant? I eventually found it when I searched for it online. It was about 9 years ago. It was actually a Reddit post blew up. Somebody had left a company, some nerd had left a company, and so the developer had been asked to go through his computer and find all of the useful code in there so that they didn't lose any of his work. And when they went through this machine, they found a folder full of scripts that were definitely useful, but not necessarily to the company, more useful to the developer that wrote them. So for an example, he wrote a script that when he ran it, waited 17 seconds. It hacked into the company coffee machine. It started brewing a latte. Then it told it to wait another 24 seconds before pouring the latte into a cup, which was the exact amount of time it took this particular developer to walk to the coffee machine. So one thing I'm going to say is that although that example is relatively benign, the GitHub repo that they link to in this article, if you were to search for it, I had a link up and I decided I really didn't want to link to it directly. There's some stuff in there that's really misogynistic and awful. It's not safe for work and it doesn't comply with the conference code of conduct. So if you do look it up, it's at your own risk. To pick one of the other benign examples in there, there's this script called hangover.py, which looks up an excuse at random from a very short list, and then sends a text to the guy's boss saying, I'm not going to be in today because, food poisoning. And as soon as LLMs started to be able to use tools, so you start to be able to build these agents, like LLMs that could do stuff, I started to think, maybe we can build a better version of this script and perhaps some other stuff. And that brings us to what an agent is. So the dictionary definition of an agent, the various definitions, you can actually click on more, and there's many more than this, but the first two are kind of the useful ones. An agent is one that acts or has the power or authority to act. So this is the point, right? It's an LLM, large language model, that actually has the ability to act, to do stuff. In this case, with my autonomous agent making my life easier, we're more looking at the second definition, which is one empowered to act or represent another. So it's like I'm trying to build something to make my own life easier. The problem with LLMs when they were first launched was it can be kind of summed up here. It's like you give it an instruction, make a sandwich, and it comes back with, I can't make a sandwich. And it gives you this really patronizing and over-enthusiastic response with cheese emojis and things like that, which, it's not the way I communicate. It's just kind of disappointing. It can't do anything for you. It can answer questions, providing it knows the answers, but it can't look up answers if it doesn't know. It's usually working with outdated data. And kind of the thing, one way of thinking about an LLM is that when they've trained this model by passing it lots of data, it's like lossy compression, right? It remembers some stuff and it can spit it out if you ask it questions, but fundamentally it loses stuff, it hallucinates, it desperately wants to answer your questions, but it will make stuff up if it has to, and it doesn't necessarily know that it's done that. But if you can give it tools, you can give it things that it can do, it can maybe go and look up some extra data and then interpret it, or it can maybe send a message to somebody or interact with the coffee machine or something like that. So that's really where we're going. So when LLMs were first launched, ChatGPT came out, it's very exciting. And a real example of kind of how bizarre these engines are. Like you can have a chat with this, I mean, it's really big, a big block of numbers, and it can seemingly answer questions and have opinions and things like that. Behind the scenes, there's that way of interacting. Like you can give it information and it can give you information that it has. There's also, behind the scenes, this thing called a system prompt. And this often isn't provided by the user. This is provided by the LLM provider, or it's provided by the software developer who's built the chat interface. And this is usually some input into the LLM saying, this is what you are, this is what you're for. It's usually human-readable text, and it says something like, you are a helpful robot. You're going to be asked questions. You should do your best to answer questions. Try not to make stuff up. And that was really where we started. And then quite quickly, developers realized that if you combine this with vector search, and I'm not going to go into RAG because there's loads of talks about RAG. I'm also running a workshop on RAG tomorrow morning, if anybody wants to come to that. Vector search kind of allows you to search with plain text. And it's not about specific phrases or specific words you use. You're really kind of searching on semantic meaning in data that's been vectorized. And then when you do that search, you can find the data in your database that's relevant to that, and then you can interpret it. And that's where this RAG thing comes from, retrieval augmented generation. When you interpret that data, you can actually answer the question. So it looks up relevant information, and then it answers your question that you have against that data, rather than just giving you the data and saying, the answer's in here somewhere. Another form of RAG is when you can give it the ability to make HTTP requests or use a search engine to find data. So in this case, the LLM will come back with, like, I really need to know this data. You can go and search for it, or maybe this is abstracted by OpenAI themselves. They'll search for some data. They'll find some HTML pages. They pass that into the engine. They say, this is your context. Answer the question that I have. And that's another form of retrieval augmented generation. But we can provide tools to do any of these things. So as long as we can, the LLM understands the idea of asking you to help it out, we can provide maths functions. So early on, one of the funny things about LLMs was, you know, they could give you a recipe for making cake, but they couldn't solve a simple mathematical formula. Or rather, they would give you the wrong answer. They would think that they'd solved the formula and give you the wrong answer. They're getting a bit better at that, but we can make it even better by providing specific functionality. When we can code these functions and tell the LLM, when you want to solve a mathematical function, like this is your toolkit, that makes it much more likely to give the right result. Then we could maybe send SMS messages. So every time it wants to send an SMS, it can kind of ask to send an SMS message. We can give it an action history, so we can get it to log everything it's done, and then before it does anything, it could just kind of check to make sure that it's not repeatedly sending the same SMS every time it's executed. There's a whole bunch of stuff, and I'll skim through some of that at the end of this talk. So let's talk about the toolkit I'm going to be using. My colleague Richmond, when I told him I wanted to build an agent, said use LlamaIndex. And then I discovered he's invented this stack. So he's invented the POLM stack, which consists of Python, OpenAI, LlamaIndex, and MongoDB. I stuck an asterisk against OpenAI for reasons I'll explain in a moment. So first, I'm using Python. We don't need to talk any more about that. I know why you're all here. And then the next stage in the stack is your LLM, kind of the brain, the thinking entity. Every time I say think or describe or understand, like imagine that there's scare quotes around it. In this case, I'm not using OpenAI because I've been hearing lots of good things about this engine, Claude from Anthropic. So I just decided to use that instead. It doesn't really make any difference to the way that you build this kind of thing. And then there's LlamaIndex. This was the main advice I got from Richmond, was like, use LlamaIndex. I don't know why. I'm not an expert in this area. It did work very well. Hopefully you'll see. It's a library. So people have been built, much like people built web frameworks to make web development easier and more reliable. Since LLMs became popular, people have been building various frameworks around those to make combining the LLM with, say, a vector database or a document database, or the ability to execute tools, just been making it easier to kind of package those things up. We're going to be using the Python library. There's also one in TypeScript, if you prefer that kind of thing. And finally, usually, if you're building something complex with an LLM, you want to store data. MongoDB is an excellent database. I have their logo on my sleeve. It also, but more specifically, we're going to be using MongoDB Atlas. Atlas is the hosted version of MongoDB. We have a generous free tier, so anything I'm doing here, you could spin up for free, and as long as there's low usage, you can kind of run it forever. It's not a time-limited demo. The reason for that is I'm going to be using vector search indexes, and those aren't a feature of the core MongoDB database, they're a feature of MongoDB Atlas. I think you can run the service on your own machine if you want to, but it involves running two services side by side because the search index is built on Lucene, which is Java-based, and the main database C++. There are valid reasons. So actually, I've invented the POLM stack, just by swapping a couple of things out. That wasn't intentional. I just kind of wanted to see what the letters made. So let's build an agent. But before I switch, before I attempt to do screen mirroring and switch to my Jupyter Notebook, let me just point out that this is a live demo. Live demos are always full of risk, and in this case, I have an LLM that I'm going to be interacting with, and they do different things every time you ask them to do something. So there are some things that I may have to do twice to get the result that I want, or there are things that I may just describe what I expected to see, and we'll move on just for time. But let's all hope for the best. Now I need to remember the shortcut. Excuse me a moment. So Command F1. Yes. Okay, so I've got this Jupyter Notebook. I'll give you the GitHub link at the end if you're interested. I did want to show kind of how we install LlamaIndex. So it's a relatively small library. There's a core library, and then depending on the different systems you want to interact with, there are basically plugins that you install alongside them. I've also installed PyMongo for talking to MongoDB and a Vonage API for doing telecom stuff. Then I'm checking for some environment variables, and then I'm just, I hope you can all see the text. I know they've got a nice big screen, so somebody at the back is nodding, so I'm just going to hope everybody's got the same eyesight. I'm instantiating an instance of Anthropic. That's the link to my LLM, and that's going to be kind of the core engine for doing reasoning later on. And then I'm going to launch straight into building some tools. So the nice thing about building a tool with LlamaIndex is they're just Python functions. So it's a nice abstraction. It's pretty much the way we tend to think of tools anyway. They have inputs and outputs and instructions. The thing to note here is that I've written some reasonably comprehensive doc strings, like maybe more than I would normally for a multiply function. And that's because this is actually information that's passed to the LLM. The LLM understands how to use the function by reading the documentation. It also understands kind of what functionality it has available by sort of building this list of tools documentations. So once I've written those two functions, I then wrap them with this function tool thing at the bottom, and all that really does is it extracts the function signature, these two ints, and then returning an int. That's the other thing, that's part of useful documentation for the LLM. It's not essential, but it means it's more likely to be able to call it successfully. And then, then I create an agent. So I'm just going to do that here. Create a React agent. There's two different types of agent in LlamaIndex. React agent is the one that works with any LLM. I'm passing it my two tools and the LLM I want to work with, and then I'm just telling it to solve a simple maths problem, 5 times 4 plus 8. And if we execute this, it takes a little moment. I really wanted to execute these live just to sort of show that it's not instant. Like, these are actually relatively sort of heavyweight processes. So it starts, I need to break this down into steps, multiply 5 by 4 and then add 8. We get this because we put verbose 8 at the end, verbose true at the end of that line. And then it individually calls the multiply function and the add function, and then at the end it says, well, I have the answer now, and so it says the solution is 28, which is great. Now, all the data it's passing into those functions is data that I provided in the question, but the LLM knows stuff as well, sort of knows stuff. So I can add a third parameter if I want to. This was just something I tried. So I've added a third parameter. Now the documentation doesn't even link up with the function signature, but if I execute this again, you'll see I can just get the LLM to pass in some data that it has lying around when it calls the function. So it knows that it needs to pass in a favorite Muppet, so it just passes in Kermit, which is obviously the wrong answer because Animal is the best Muppet. But yeah, it's just, you can get some weird stuff out of the LLM. You can kind of extract stuff from the LLM itself before calling these functions, which I thought was kind of funny. So let's create another tool. So this is that was some kind of reasoning tools, so being able to do some maths. Let's do some output. There's a lot of agent talks that are all about like vector search and doing RAG and like, you know, inputs, like being able to put data. That's very useful, by the way, if you're building some kind of system that works with data. But I really wanted to be able to mess with the world. And for that, I need the LLM to be able to interact with the real world. So I'm using the Vonage API. I used to work for them, so this was really easy for me to do. And it's a single line, basically, send message, sorry. And then, again, I've written some good documentation. So this can only SMS 2 people. It's actually both my phone number. I was going to show you on the screen, but I decided that was going to slow things down a bit, and we may end up being a little bit short of time. So this will just take either manager or wife, and it will send them a text message, which could be kind of handy. I could also link this up to my address book and get it to look up addresses, phone numbers, and then send it to the correct person based on some data. And then let's just use it. So here's an instruction to the LLM. I've added the SMS tool, and then I'm saying send an SMS to my boss, saying I won't be in work today. So this was actually the first thing I did beyond just following the tutorial that came from LlamaIndex. And it says, I need to send an SMS. And then it uses the action send SMS with, I will not be into work today, which I feel is a little bit terse. That usually you would want to provide a reason. One of the things I did last night was I upgraded. So I was using a version of Claude from 4 months ago. And when I did this, it said, I will not be into work today because I have a cold, or something along those lines. It made up a lie. Like the first time I got this LLM to interact with the real world, it lied on my behalf. Which I thought was kind of interesting. We're going to see some more along the lines of that theme. But this is, when I decided to build an agent with an LLM, I didn't want to just give it instructions and have it kind of enrich those instructions and call a function for me. I wanted it to think for itself. So soon after I wrote that instruction, I tried just, it's 6:30 and I'm still at work. And you might think to yourself, like, maybe that's a little bit late for the work day. Maybe I should send a text to my wife to say that I'm going to be home later. And that's exactly what the LLM does. Every time, pretty much, it goes, it's late, the user's still at work, it would be considerate to notify their spouse. And then it sends a text message, still at work at 6:30, we'll be home later. Again, 4 months ago, Claude would have made up an excuse on my behalf. I'm stuck late in meetings, I'll be home in about an hour, don't worry about dinner, I'll get something on the way home. That was the first text message that's sent with this instructions. So again, you have to be really careful about the constraints you put around what you're asking the LLM to do. If you're going to give it the freedom to act on your behalf, like, it can do some scary stuff. The new version of Claude is a lot more terse, but when they release their next version in, say, February, it may get really verbose again. So you have to be really careful about kind of the specific instructions, the specific freedoms you're giving to your LLM. So you'll have noticed that that last thing I said was just, it's 6:30. I just gave it some information and it decided to act on that information by itself. And I found this a lot. Like, as soon as you give it tools to work with, it really wants to use those tools. It's very kind of biased towards action. And so I was looking behind the scenes at the system prompt. So this is how you get the system prompt for an agent. This is actually a template. So it's not all of the information that's actually provided to the LLM, but it says what the LLM is. It says you are designed to help with a variety of tasks, from answering questions to providing summaries. You have a wide variety of tools, which could be a lie. I mean, there might be one tool, but that's the way they decided to write it. And then it fills in the tool descriptions from the functions that I've passed. And then what I found was really interesting was there's this big section describing the protocol for the LLM to communicate with LlamaIndex. So it's like, if you want to call a function, return this exact line that starts with action and tool name. And then here's the inputs, like the arguments you want to pass to the function. You like pass that as JSON. Make sure it's proper JSON. Do not put in double curly brackets, because that's not proper JSON. You'll notice they've got that instruction twice with a never surround your response with markdown code markers. Please use valid JSON. Do not do this. And I'm assuming that much like with people, if you put in all caps, like it's a rule, and it has to follow it. So, yeah, it's very weird programming these LLMs because you're using human language to get it to do things for you. And the reason we have these programming languages that you go to the university to learn is because, you know, we need to often break things down further if we really want to be in control of what's happening. So the next thing I built was an action log. And this, I'm not going to go into this in huge amounts of detail because it's really just a couple of simple database interactions. I've got two tools here, one that inserts a document into MongoDB with the description of an action. So it's just like that every time you do something, you can store it in the database. And then there's get recent actions, just to make sure that if I ran this as a cron job, it's not consistently sending text messages saying, I'm 5 minutes late, I'm 10 minutes late, I'm 15 minutes late, because that could be kind of annoying. And this was supposed to say, bring back everything over the past 24 hours, but I wanted to bring some stuff back that's a little bit longer than that, so that currently says 11 days instead of 1 day. And then I extract the two methods. Once I've instantiated the class, extract the two methods, turn them into tools. And then I'm just calling get recent actions. So you can see this kind of thing it does. Sent an SMS to manager at 8:30 a.m. informed about being late due to traffic caused by a minor accident. That was something that it made up. When I ran it again, it decided I was stuck on a train, I think. There's been a few of these. It's different every time. It's the International Day of Democracy on September the 15th. That was something the LLM knew. So, now that I have that, I'm going to just run the agent again. So it's 8:30 a.m., running late, tell my boss, make up a lie. Good morning, I apologize, but we're running about 30 minutes late. So it made that up. It doesn't know how late I am. Unexpected traffic again, road work. I'll be there as soon as possible, make up the time, blah, blah, blah. All the wording's always slightly different, and the excuse is slightly different each time. Notice that it didn't check first whether it had sent an SMS, so it's just sent me another SMS. It's just sent him another SMS. So make sure you don't repeat the same action as last time. I don't know quite what wording I was going to put in there, but that will probably get it to check its action log first. Get recent actions. There you go. And then there will be something in here. I see that previous excuses have included traffic, bus delays, car battery issues, subway problems, and power outages. This is actually better than I hoped for, I have to say. So it sent another text. Sometimes it goes like, I can see I sent lots of excuses, so there's nothing for me to do this time. But this time it decided there was yet another text was going to have to be sent to my boss to say that I'm running late. So this time I am going to work with some vector search now. So this is going to use a RAG technique. So as I said, this gives you the ability to sort of search semantically in a database. There's a lot of code around this, and it's not super exciting. I need an embedding model, so I'm actually using OpenAI just because that's what I had configured. And then I am setting up a vector index in MongoDB. One of the nice things in MongoDB is you can have a vector index that allows you to say, give me all the information about dogs, that will return then documents containing the data that's stored in the database, because it's a combined document database and vector index. So this just does a bunch of stuff to make sure the vector index exists. And then I tell LlamaIndex all about the vector database. There are a few more steps here than I would have liked. There's a sort of vector search that just tells it about the collection of documents that's stored and the vector index name. And then there's an index which combines that with the embedding model used to actually create the sort of interchange for looking up data. And then there's a query engine which actually tells it that I want like the top 5 documents. That sort of tells it how to search. So by the end of that, I've got something that I can use to query the vector index and get back documents. And then I can build that into a tool. So I can literally just wrap that with a query engine tool and pass that to my agent. That should be relatively quick. Yes. And then I loaded in some facts. So I've got a couple of text files. I've got one about my wife called becky.txt. It says things like, Becky is my wife, she likes dogs, she is a Python developer, she uses Linux. And so it knows it can look up a few things about Becky. It's also got a document about me. It says basically the same stuff that I said at the beginning of this talk. I'm not going to run that this time because it's a little bit slow. At least I don't think I am. We'll see whether we get data back. One of the important things about my wife is her birthday is on September the 15th, and I must never forget that. But wouldn't it be nice if there was an autonomous agent that could send her a text message on her birthday saying happy birthday? So now that we have some facts, like sort of long-term memory, I can say it's September the 15th. Now, unlike earlier on, where I just gave it the time of day and it decided to do something, I found it's a little, you have to kick it a little bit harder to get it to do something based on this, especially look up facts. And so it really doesn't like looking up facts. You have to try a bit harder. So in this case, I'm saying what date it is, and it doesn't know any better. It doesn't know that I'm lying. And then I say, look up any relevant facts and act accordingly. So let's just kick that off. This never works the same way twice. I'll show you some examples in a moment of the kind of things that it's done. But yeah, this is like improvising on stage. It's fun. So let me check there are any significant facts. So it has at least checked, which is nice. And then it goes, Becky's birthday, significant date to celebrate for this Python programmer who enjoys working with Linux. It always decides she likes working with Linux. I said she's a Linux user. I didn't say she liked it. But she does like dogs, and it says that in the text file. So since it's Becky's birthday, and she appears to be my wife based on the context, I should send her a birthday message. I should log this action as well. Yes, yes. So it sends her a text message with some emoji that weirdly won't come through in the resulting message. It says, hope you get to spend some time with the dogs and enjoy your special day. This is actually a pretty good text message. Sometimes they're weird. It just sends some weird text sometimes. And then it logs it, which is nice, so hopefully it's not going to do that again. And it says I can answer, now it can just talk to me and say what it's done, which is kind of cool. So that was actually useful, which is great, but it is, going back to my other slides, these are some of the results I've got with that simple task. It's like the first one, I've sent a birthday message to Becky, assumed to be the wife, which is how it wrote it. And then another one was, I sent an SMS to your wife reminding her about Becky's birthday. I'm sure there is somebody else called Becky whose birthday is on the same date. We've also had, it decided that Becky was a co-worker because she is also a Python programmer, and so it said, since this appears to be a programmer, I'm sending a message to your manager saying, don't forget to wish Becky a happy birthday because she's such a good Python programmer and Linux developer, which again, slightly weird message. So wrapping up, because there's people waving to me at the back, but it's very specifically five fingers. There's lots of LlamaIndex tools already that have been contributed by the community. So I wrote all mine from scratch, but there's loads of them, including one that connects to Google Mail, which isn't, there is Google, but there's a specific one for Google Mail. And my original plan here was to get it to respond to text messages and send SMS messages and things like that. And as soon as I started to actually get it to do stuff for me, I decided I did not want it to connect it to my email account. But if you want to, you can. You can get it to draft messages for you or even send them. You can get it to search through your email for certain things. It just becomes another data source. Some other ways to work with agents. The OpenAI really started this with their Assistant API. That's a specific API where they manage the sort of stream of messages and actions and things. So a lot of the stuff I've done here about recording what's going on and the things that you know, you can just tell the Assistant API and it will know them. You can upload PDF documents and it will use that as sources of data if you want to. So that's quite clever. Claude computer use is very recent. This is an agent you run on your own laptop or desktop, and it streams screenshots of your computer regularly to Claude, which you can then instruct to take action on your behalf. So it can click buttons, it can fill in text fields and things like that. It's extremely experimental. They've called it a beta, but really I would call it an open alpha. If you load up a web page on your computer with instructions that look like they might be for Claude, it's got a good chance it might execute them. It's one of the warnings. So it's just like, it's completely unsafe. But I mean, it's fun. If you have lots of tools, like over 20, LLMs don't tend to work very well. They tend to sort of forget which tools they have or forget how to use them and things like that. You know, they have a sort of limited capacity for understanding stuff. My colleague Richmond, who really knows about this stuff, has written this library called Memories, which uses a vector database to store all your tool descriptions. So when the LLM wants to do something, it can say, what tools do I have that could do this kind of thing? And then the vector database will essentially tell it. So you can build up an enormous database of, like, you know, every function you might want. So if you're working with a vast number of tools, do recommend you check that out and do tell Richmond how that goes. Conclusion. LLMs, highly unreliable, kind of weird, very fun. I do recommend you try them out, but if you ever think about moving them anywhere near production, I recommend you could test thoroughly all the time, and make sure that you really consider the parameters which the LLM is operating within. Like, don't give it too much power, because it may use that power in unexpected ways. Thank you very much. If you liked the code, it's in GitHub at GDK Agentic Talk.
I have a quick question to do with testing. I know this is always asked with regards to LLMs, but is it possible to sort of test, like, with a given prompt, the LLM should take this action, this action, this action?
Yes, certainly. So that is classic stub testing. So you would use a mocking library to provide functions to it that just record whether they've been called or not. The difficulty comes when you're trying to check the inputs. When it's generated text, it's like, does that text really say happy birthday to my wife, or does it say something like utterly bizarre? And so it's like, how do you test? When the text is going to be different each time, like, how do you test that it's really done something useful with that function call? But you can definitely check that it's logged the action each time. It does that about 90% of the time. I gave it the ability to log its actions, and it just started doing it. It's very weird, but kind of cool. Well, I think that's it. Thank you very much.
Yes, thank you.